Hello and welcome everyone. My name is Kelly here with Esri, and I'd like to thank you for joining us on our webinar today. So today we're going to be discussing GIS, spatial analysis, and statistics. And with that, I'll go ahead and introduce all of our presenters today for you. So first we have Hannah Shumway. She's a solution engineer for Intel here at Esri on our national government team. We have Brady Ross, also a solution engineer on our civilian science team and also supporting our national government team. And we have Linda Peters joining us today from our global business development team for our Esri national government. So Linda, thank you and welcome, and I'll pass it over to you to get us started.
Thanks so much, Kelly, and welcome to everyone. We've got a lot to cover here for you today. So I just wanted to go over an agenda with you really quickly. We're going to explore how you can discover patterns and trends in your data with ArcGIS. We'll start with a little context of data science and GIS, and then I'm going to invite my colleagues Hannah and Brady to show some examples, and then again at the end we'll open it up for questions. For those of you from ISI who are joining an Esri webinar for the first time, we welcome you and hope that you find the content useful. So with that, I am going to start with the ArcGIS platform. Many of you know already that ArcGIS is a comprehensive platform. It's open and services based. It's distributed and extendable. And it supports not only large organizations or teams, but also individuals. And it provides us with a smarter way to perform analysis and now data science. Now, when we think about ArcGIS, it continues to evolve. It has been integrating many new innovations in data measurement, in computing, and in science. We're integrating new data sources from drones or from satellites or other technologies, new tools for computing, faster machines, of course, but also AI and machine learning capabilities. So a lot is happening within Esri, within the ArcGIS system. And in spatial modeling and analytics, it's advancing science and creating whole new insights. For example, in big data and real time, looking at multi-dimensional data, looking at object detection using AI and machine learning, or remotely sensed data coming from so many different sources today. These are assisting people by leveraging the latest technology and being open to the world of open data science and new tools that are emerging in the community. Now, as we begin today, as we start to think about spatial analysis and data science, we need to think about our approach. We don't just do data science. We start with a problem. We identify the people we're going to work with. We find and prepare the available data. We visualize, explore, and analyze that data. And then we choose the methods that we're going to use to help contribute to an answer. And data science and machine learning are part of the analysis, that messy, iterative, sometimes painful, but always rewarding process of analysis. Now, we're going to focus in two key areas today. We're going to take an in-depth look at data engineering, perhaps not the most exciting task, but a really important one. It's all about cleaning your data, getting it ready to put into a tool or a model. And this is where most analysts and data scientists spend a lot of their time. It can include anything from a simple field calculation, analyzing correlations, to reduce the dimensionality of a model, to geo-enrichment and much more. So we'll take a look at that in depth. And then we're going to talk about analysis, spatial analysis. As we move into spatial analysis, we're talking about a set of exploratory techniques for describing and modeling spatial distributions, patterns, processes, and relationships. What do I mean? There are different methods for analysis, such as clustering, classification, and regression. Here is an example of clustering, grouping observations based on similarity. Tools that can help us with clustering include spatially constrained multivariate clustering, density-based clustering, image segmentation, hotspot analysis, and others. In classification, we have to decide which category an object should be assigned to based on a training data set. Tools we might use here include random trees, forest-based classification, and regression. And finally, in regression modeling, determining the strength and character of relationships between dependent and explanatory variables. So we might use kriging, do an aerial interpolation, use linear regression or geographically weighted regression. There are many different types of tools that you can use in this area. And why do we do that? Because all of these tools can help us with our analysis, whether that is descriptive, predictive, or prescriptive, helping us to understand what has happened, what could happen, or what we should do. Now, with that, I want to stop talking and get Brady and Hannah in here to give some demonstrations. But first, I'm going to ask Kelly to give us our first poll question. Kelly?
Yeah, thanks, Linda. So I'm going to launch our poll question. Everyone should be seeing that on their screen now. So go ahead and select the best answer that applies. So in this question, what area would you be most interested in learning more about in data science? So you can select more than one answer here. We have data engineering, visualization and exploration, spatial analysis, modeling and scripting, machine learning, AI, and big data, and sharing and collaboration. All right, and it looks like a good majority of you, 88%, are interested in spatial analysis, modeling, and scripting, followed by visualization and exploration. So
That's
again,
great.
yeah, thank you. We appreciate that. We appreciate your feedback. And I believe, Linda, we are going to go ahead and launch into those demonstrations. Is that correct?
Yes, please.
We have a demonstration that we've pre-recorded for everyone. So this is from presenters Hannah and Brady. So we're going to go ahead and play this. And again, this was pre-recorded for accuracy and for your convenience. And then we will have a live Q&A session on this exact demo with Brady and Linda at the end of this. So make sure your audio is working, turn up those mics, and we'll go ahead and get started.
Welcome to What's New in Spatial Statistics with Data Engineering and Advanced Analytics in Arcgis Pro 2.8. I'm Brady Ross. I'm a solution engineer for the Science and Civilian team, and I'll have Hannah introduce herself.
Thanks, Brady. Yeah, I'm Hannah Shumway. I'm a solution engineer on the Intel team, and yeah, excited to be here and sharing some new stuff in spatial stats with y'all today.
So let's get started. So currently, Arcgis Pro has thousands of tools for analysis and data science, which encompass most, if not all, of these patterns of spatial analysis. However, very few of these tools are dedicated to cleaning up and setting up the data. And anyone who uses data in any context knows that setting up the data correct takes up the vast majority of your time. Within the data science realm, there's a concept called the 80-20 dilemma. This states that users spend about 80% of their time searching for, organizing, and cleaning their data, and only around 20% of their time analyzing their data, which can be the fun part. And in GIS, this doesn't leave any time for visualization. So this is where data engineering comes into play. It's a powerful new view in Arcgis Pro that delivers a slick user interface dedicated to giving the user that robust knowledge to minimize the time spent cleaning the data and more time analyzing for your key analytics. All in all, Arcgis Pro is a powerful spatial data science workstation that's intuitive to use. And we believe this should be translated to the data engineering and spatial analysis tools. So we brought these key capabilities with this new release. We can spend more time in analysis and visualization and less time filtering through and cleaning the data. The best part is Arcgis Pro is built for everyone. Anyone can simply put their data into Arcgis Pro, scan it, fix it, and move on to analysis. Today, I'll be demonstrating the new data engineering view here on the left through two demos. And then after me, Hannah will be demonstrating some advanced analytical tools here on the right. So let's hop into it. So here we are in Arcgis Pro, and we're currently looking at the counties across the United States. Within the past year, we've been looking a lot at COVID-19, and now we're starting to enter into this new storyline for this history, and it's more going to be related to COVID vaccine hesitancy. So I have data here by the CDC with multiple other variables, And we can start looking at where locations are hesitant, where locations might be more vulnerable to the release here, and also some other spatial patterns that we might be able to find. So let's get into this with data engineering. I can open up the data engineering view. And here we are. It's split into two panels. On the left is our fields view, where we can start seeing all the fields with our data types indicated by an icon right next to the field. And on the right, we also get these two icons for update symbology and create chart. This allows the user to quickly see what that variable is in the map above. So you can quickly see that we're now going by estimated hesitant here. We can also create a quick chart. So just like that, I already have a chart created, and now we can select the top top bins here and see kind of where the counties are that are most estimated hesitant for this COVID vaccination. So I'm going to go ahead and drag some of these fields into our statistics view on the right. So as it's calculating, we get all sorts of these stats. Now, don't be shy. These stats are pretty straightforward, and they give you really good knowledge about your data. But here we can see our fields view, our alias, another category for our field type. But we also get this number of nulls column. This is a valuable statistic to know because nulls can show you holes in your data or where you might need to fix your data. So looking down here, we see the social vulnerability index has one null. Now, if I base my symbology off the social vulnerability index, this is a category to show which communities might be most vulnerable on a social level. So it could be more than one family household in a single household. It could be lack of access to a car to go get your vaccination. It could also be some economic and demographic data all thrown into this one index value. So we can see here in the map, a lot of these communities are in the southern part of the United States. But notice we still have this one null. If I select it, we can see that it's this null value here in Northwest New Mexico. So we can go ahead and fix that. I'm going to clear that selection. And we can fix this value here by fill missing values. So here we can choose our fill method and our spatial relationship type, but everything's already run. Everything's already set up for this. So I'm just going to run it. And I'll just take a few seconds here. And so what it's doing is it's looking at all the counties around it, and it's spatially aggregating what a value could be for this New Mexico location. And it automatically adds these new fields to our table here. So I can drag this in. I can recalculate. And now we can see this value has no nulls. And now if I symbolize by it as well, we can see that county is filled in on the map. So there we go. We already have field missing values for one of our data fields. Continuing on with this number of nulls, we see this field, this adults fully vaccinated against COVID-19, has about 316 nulls. So let's go ahead and look at that field. And then we can select which counties are null. And we can see this is majority Texas, New Mexico, and a few counties spread throughout the US. With this information, I'm going to be fine leaving this as is. I'm going to take note for any future analysis, and I'm probably going to delete these rows for future analysis with this field. But since it is statewide data not being filled in, I'm not going to populate it with answers here. And so keep going down here through the data engineering view. We can see this chart preview of all our variables. We can even see some demographic data here, such as the percent Hispanic and estimated percent Asian, Black, and American Indian as well. So if I'm the CDC with this new map here, we can see the percent Hispanics largely concentrated in the South and the Southwest. And if I want a marketing campaign to address some vaccine hesitancy, this is kind of where I want to focus. But if I look at the histogram, we can see that this is skewed heavily onto the left. If you want to perform any analysis, most analysis tools down the road will require a normal distribution for your kind of true statistical needs. So we need to fix this. We need to go from this left-leaning, left-skewed analysis to a more normalized bell-shaped curve. So we can go ahead and do that. So with this transform field, I can overwrite the field here and press OK. And it's also just going to take a few seconds. So if I recalculate, we can see, change up that symbology. If I recalculate, we can see that graph went from this left skewed graph to this more normalized distribution. Now, if I also open this new chart here, we can compare that to a normal distribution. And we can see that it fits our normalized distribution a lot better. So scrolling right now as well, we start seeing all these other statistics for our fields. We have minimum, maximum, mean, standard deviation. And keep going, we have all sorts of cool statistics here. Now, one of my favorite things is if you right click in any of these fields, you'll have the appropriate tool that a user might want to apply for this field, such as transform fields for skewness, which is what we just did. And then take that even a step further. If you want to automate any of these processes, or if you have data that you want to give to a colleague and they can perform the same processes, all these tools are geoprocessing tools. So they can be thrown into a model or into a Python script, and you can automate those as necessary. With that, I kind of want to transition a little bit, but before there, I wanted to review this. We quickly filled in our missing values with our field missing values of the number of nulls, and we also fixed some of the left skewed graphs to become a more normalized distribution with just a few clicks and tools. So it makes it a pretty easy way to start looking at your data with this data engineering view. And now I want to take a look at another US-wide kind of issue here, and that's going to be air quality. Air quality is really important because I just moved from California, and we know those wildfires kind of spread throughout the US and provide kind of a bad air quality for us to breathe in. And so first I need to find data. And thankfully with that, there's these sensors called Purple Air. These are small sensors that you can place inside or outside. You can purchase them for about $250, and they have built-in Wi-Fi, so they sync up to your phone, and you can get live time analysis on like 10-second intervals, 30-second intervals to a day intervals on what your air quality is like outside. Purple Air also has a map. So this creates a kind of a citizen science project where you can get air quality from different sensors. And looking at Redlands, California, we can see who already has these sensors in the location here. So if I click on one of these sensors, we can see it's a 10-minute average for particulate matter at 2.5 micrograms per cubic meter. We can also see the air quality is at about 120, which is going to be pretty high and pretty dangerous already. We'll also get kind of a quick rough view of previous recordings. We can also see that this is done right as we achieve scientist Batcave. So I've gone ahead and downloaded this data and brought it into Arcgis Pro. I already have the data engineering brought up, and so we can see that we have a time frame with our dates here, and we also have the particulate matter variable here. So let's look at this histogram, or let's look at this line chart across time. So here we can see all these spikes going up all the way up past 800. If we remember on the Purple Air, we were getting about 100 or so PM measurement already at the red level. So we can see some of these spikes seem really way off. So this is something we might need to fix. One common criteria or one common critique of Purple Air is that it's almost too sensitive. These sensors sometimes can detect the garbage truck driving by with the emissions there, or it could even be Don Wright's monster truck idling in her front garage with a sensor. So this would be a good example of how to smooth out the data and get this true values for this recordings here. So let's go ahead and smooth this data. I can use a new tool called time series smoothing. I'm going to input my date field here. And I'm going to backwards average smooth by about 1 day. Once it all validates, I can press OK. This is going to take about 2 to 3 minutes to run, so I've already pre-ran it. So let's look at it in the chart. I'm going to bring this value into my chart. And so with this, we can see from our previous raw data in the light blue, we can see with the dark blue that we really smoothed out those spikes in the sky or spikes in the air. We can see that also we have this spike reading here from early September to November. So if I turn off our raw data, we can see how high this actually did spike up to. Now, when I lived in Redlands, I was living during this time, and I remember for about a month, like a lot of the skies would be bright red. It would be pretty abhorrent to go outside and breathe the air. You would also get warnings on your phone to say, don't go outside or don't exercise. And so during this time from early September, if I turn on some fire parameters, this is exactly during the El Dorado fire, which is that famous gender reveal fire that was started from a gender reveal. And also right before that was the Apple fire. So it's kind of this conglomeration of bad air quality for about a month straight. I have a photo here from my time. It's not a direct photo of the sky, but I think you'll be able to see at least what the air quality did look like through a window here. So it was kind of like that for a while. And so with that, I'm actually going to pass this demo over to Hannah, and she'll show you some of these advanced analytical needs.
All right, so as Brady mentioned, I'm going to go a little bit further into some of the advanced analytical tools that we have available in the newer versions of ArcGIS Pro, and also still leverage the data engineering view a little bit because there are so many different ways that we can implement different workflows with the data engineering view. So I'll just jump right into it. I've got some data from ACLED, the Armed Conflict Location and Event Data Project, and those folks are partners, so we have good access to their data. And we have data specifically on violence against civilians events across the world and over the past 5 years. So we're looking at data from 2016 to just May 1st of 2021. And we might be interested in saying, hey, well, where are clusters of violent events over time, and how do we understand these violent events so that we can stop them from happening in the future? So the first thing we'll want to do is open up our data engineering view, and we can start to pull in a few different interesting fields that we might want to learn more about. So things like sub-event type, fatalities, even something like this event date field. And when we go to calculate those, we can immediately start seeing, if we look at this chart preview, that about 90% of these points, these events, the 90-some thousand of them, are attacks. And we can also see that the distribution of fatalities is hugely right skewed, given that the majority of these events are maybe 0 or 1 fatalities, but they range up to 600. So we're starting to get a sense of what ACLED's really tracking here. It's not necessarily mass fatality, violence against civilian events, but little ones as well. So we also have, and this could be particularly important for our future analysis, this event date field. And unfortunately, right now, this event date is stored as a text. And in order to do further analysis on it, we're going to need this event date as a date type field. And luckily, all we have to do is go in and format this field with the convert time field tool. Now, the only thing that we'll need to change within this tool is the input time format. And if we go over and see the mode, for example, we can understand what format we need to put in order for ArcGIS Pro to read our date correctly. So we seem to have a 2-digit day, full name month, and 4-digit year. And so we'll just key that in. And when we click OK, this creates an additional field for us with a time converted. So it does take a couple of minutes to run, so I've already done that for us here. And what we can do is see that now, luckily we've got a date field, and we're also able to explore the temporal distribution with the chart preview, and a couple of statistics were calculated for us. And now as we're going forward, we can start to do some of that really rich spatiotemporal analysis that ArcGIS Pro allows us to do. And today we're going to start some of that analysis by using the density-based clustering tool. And now you might know of the density-based clustering tool. It has been in ArcGIS Pro for a little while now, but now it has the addition of being able to bring in your time information as well to do that spatiotemporal analysis. So density-based clustering, what it's doing is just finding clusters, spatial clusters based on your data, and trying to filter out some of the noise, things that might not be as significant to you if you're looking for those spatial clusters. So what we're doing as we put in the different inputs here is basically defining what a cluster looks like to us. And this can vary a ton based on the data that you're inputting. But for us, we're saying that we want to have at least 500 features in a cluster, and they have to be within 200 miles of one another, and they should have happened within 3 months of one another. So that's what we're saying a cluster is. And as we run this, you can also note that our time interval, our search distance, our minimum features per cluster could be very different if we had a smaller data set, if we had a data set that was over only a week, anything like that. But the density-based clustering tool also provides us, and you'll see this as it begins to render, is that it provides us a couple of automatic outputs that are really rich and help us to already start to decipher the analytical tool as it comes out. So we get an automatic symbology, and that's what you're seeing with all the clusters popping in here, as well as a couple of charts that help us decipher especially this time perspective of what time span are we looking at with each of these clusters. So we'll see, we have clusters in southern Mexico and Central America. We have a few different clusters here in the Iraq and Syria region. And we can zoom in to see those clusters. If we go into our time span per cluster chart, which is this automatic chart that comes along with our output, we can see that it looks like the red and pink clusters are pretty spatially close to one another, but they have different time perspectives. So one is earlier in about 2017, whereas the pink one looks to be spanning through 2018 through early 2020. And we also have in our view this blue cluster, which while it's spatially near the other two, it is also pretty clearly distinct and has a lot more violence against civilians activity tracked over Iraq, and that's the most recent cluster. Now, this is where it really becomes important that we included time in our analysis, because if we had just done density-based clustering without time, which is what I did here, all of this nuance would have been lost. So we would have had no idea that there was maybe a changing pattern over time and more activity happening near Baghdad in the most recent time. But that spatiotemporal analysis allowed us to figure that out. So now that we maybe have a sense of some of these spatiotemporal clusters across the world, we might want to know, well, why is this happening? Why are we looking at and seeing these violent events, and why are they moving in this way throughout Iraq and Syria? Well, in order to start getting at that question, we've brought in some data on world development indicators. And we want to figure out whether the world development indicators have any impact on something like violence against civilians, or maybe they don't, and we want to figure that out too. So we have a few different variables that we've brought in. And I'll scroll down to grab them in so you can get a sense of what they all look like. But so we've got everything from a human capital index to compulsory education in years to alcohol consumption per capita. So we got 11 different indicators from the World Development Indicators. And the thing is here that a lot of customers are tripped up at this point because you have, okay, you're like, I have all these great development indicators and now I'm going to go do regression and figure out if any of them are affecting the number of violence against civilian events in a particular country. Well, that doesn't always work because we actually, a lot of the models that we are running in ArcGIS Pro actually assume that our input variables aren't related to one another. And in order to figure that out, we can open up a little bit of analysis to check to see, hey, is GDP per capita and access to electricity and foreign direct investments, are these all totally separate variables or are they somewhat related? We have to parse through that. So we can create a scatter plot matrix to check that out. And as you can see, we'll open up the chart properties so you can see what I'm mapping. This is actually Pearson's R, which gives us a sense of the correlation between these different variables. And you see a lot of dark colors on the chart here, which is a bad sign in this case because we're looking to have almost no correlation between our input variables. But right now there's a ton of different correlations that we see on the map. But luckily in ArcGIS Pro, and especially in this newer version, we have access to a tool called dimension reduction. And this allows us to create some new variables that are combinations of our input variables and that allow us to get new variables that we can input with confidence into a regression that we know don't have all of this multicollinearity or all of these implicit relationships with one another. So it took just a second and we just have this warning that won't affect us much here. And now we have, I'll just clear these out of our data engineering view. Now we have these new fields that have been created that are components. And if I add these in and calculate them, we'll notice as we create a similar scatter plot matrix that there's no correlation whatsoever between these different components, and that is ideal for future analysis. So we've just solved our issue in a couple of quick clicks from the data engineering view. And if you're interested in what's going on just a little bit behind the hood here, we can visualize, for example, our first component. And if we can even open up some of the tables that come along with, or some of the visualizations that come along with this tool to see, well, it looks like this first component that we've created has some really high values clustering, particularly in sub-Saharan Africa. And the chart that we get here tells us which of our input variables are factoring most into this first component. So it turns out that GDP per capita, human capital index, and life expectancy are all low in this, so they're factoring negatively into this new component, whereas population growth as an annual percentage is factoring in positively. So this component number one is actually a sort of aggregate development index that from all of our WDI indicators it has created for us, and that will be more robust in downstream analysis. So this principal component analysis and dimension reduction can be really invaluable for preparing our data for figuring out some of those questions like why. And though we haven't answered why, why violent events are happening yet, we are certainly much closer to being able to figure out if these variables are factoring in at this point. So with that, I'll pause and give you a couple more resources for going forward with spatial stats. I know we've thrown a ton at you in the past few minutes, and we want to make clear that, like, while we've shown maybe some flashy things and different things you can do with the new data engineering view and really interesting and powerful tools, that there are also resources that can help you and can help customers get a handle on all of these different capabilities. And that's everything from workshops, documentation, learn lessons, we're excited to talk more with you all about all this and take your questions. And
all right, thank you, everyone. We hope you enjoyed the demonstration. And at this point, Linda, if you want to go ahead and share your screen, and I believe we have one more poll question.
We do have another poll question, Kelly.
All right, I will go ahead and launch that to get us started. All right, so hopefully everyone should be seeing the poll question on their screen. So this question, are you using data science method or spatial analysis in your organization today? And for this one, just go ahead and select the best answer. Just pick one. So yes, you're using it. You're brand new to GIS and data science. Yes, you've been using it for more than 12 months. No, but you're interested to begin in the next 6 months. No, but you maybe have plans to begin within the next 12 plus months, or no, you have no immediate plans. All right, so it looks like 38% of you, yes, you've been using it for more than 12 months, so that makes us happy. 30% of you, no, but you're interested to begin. So it looks like those were the top two answers there, with the other three coming in at 14, 11, and 7%. Yeah, and then Linda, I will go ahead and pass it back to you. And then just as a reminder to everyone, if you did have any questions on any part of the demonstration that you saw, you can go ahead and put them in now into the chat questions box, because we will be having a live Q&A session with Linda and Brady at the end. So feel free to ask any of your questions and type them in there.
Yeah, exactly. So thanks again, Kelly. And I wanted to talk a little bit about the challenges that we're all faced with today, because we know in official statistics there are many different pressures. It could be smaller budgets, less staff and resources. Of course, it seems like timelines are shrinking. Everyone wants more and more information in near real time, and of course, maintain highest levels of accuracy and dealing with those data privacy concerns, right? Everyone's concerned about privacy of information. And all of these make it challenging for us to deliver on our product, on our information products. And so what I hope that you've seen here today is that using data science, using spatial analytics, it does help us to do more, maybe with fewer resources, to speed that information to decision makers. We're leveraging technology and expanding our ability to increase data analysis and information delivery, and leveraging faster GPU and computing and parallel processing and intelligent neural networks. All of these things are enabling us to work smarter, and enabling analysis with new tools, with AI and deep learning algorithms and tools, and of course location data. So with that, again, we want to make sure you've got a lot of resources. I know we have some beginners on the line. We also have some people that are pretty advanced. So a lot of different things here for you. I would encourage you to look through the spatial data science URL, the spatial stats URL, a lot of great documentation from the teams out there. And of course, some great lessons in our Learn hub, as well as a spatial data MOOC. So if you really want to take a nice dive in, try and sign up and join us in that MOOC as well. So with that, I'm going to thank you for your time. I want to leave us some time to throw it open for your questions. So Kelly, I'll throw it back over to you to guide us through.
Great, thanks, Linda. And we did have a few questions here in the chat. One I saw that Brady had already answered towards the beginning of our presentation, but I think it's relevant to everyone here, and so maybe everyone can get some use out of that. And that was, I am a complete beginner with GIS. Is there a recommended path to learn more so I can make decent decisions? So Linda, I will pass that over to you. And I saw that Brady had responded there to that user and pointed them to the Learn ArcGIS Hub. So are there any other resources that a beginner can use to get started?
Yeah, exactly. So the Learn Hub is a great resource, and we've just launched last week a new statistics Learn Hub, which have guided pathways. So I would encourage you to take a look at that. Again, those links will be shared afterwards. You'll all get an email from us. But that MOOC that I mentioned is also a really great place to start.
Great, thank you. And we did have another question here. Can you point me to Esri resources to use with species habitat distribution models? I use both R and Python. And Brady, I will push that one over to you. And I see again, you already answered in the chat there to that user, but maybe we can put that link in the chat for everyone to make use of. And again, as Linda mentioned, all of the links that you see here, we will provide in that follow-up as well.
Yeah, definitely. There's even the Arcgis bridge for Arcgis Pro if you're kind of specific into the R language, and that's also another great bridge into using R and having it integrated into Arcgis Pro. And there's even some more in the Learn ArcGIS as well, as well as other sources. So
great, thank you. And let's see. All right, next question. I would ask about the input data. This can create as GDB in a ArcMap or any software, or can this be created as GBD in ArcMap or any software?
yeah, so I think the questions here is I did just find the data from the CDC website, and it was downloadable as a CSV or as a Esri shapefile. So yeah, it is available to be used into Esri software. You can use that into Arcgis Pro or ArcMap. You can also use it with tabular data. So yeah, it's just downloaded straight from the website.
Great, thank you. All right, looks like we have a couple more questions in here. Is there documentation about analyzing data from satellite imagery?
Yes. Yeah. Brady, you want to go first? I'll go after. Please.
Yeah, there's plenty of documentation out there for imagery, raster analytics. It's a really fun kind of dive to take in there, but yeah, the Learn ArcGIS is going to be a great resource for that, as well as other YouTube and Esri sources.
Yeah, there's just a ton of documentation, as Brady mentioned, and there's actually also a nice imagery learning path. The Esri team has been working on developing several deep learning models as well. So we have many different deep learning models that can help you do different things, such as extract buildings from imagery, extract roads, other features, trees, power lines. So there's an amazing amount of tools that are already out there in the deep learning libraries to help you get started.
Great, thank you. And next question, I cannot see ArcScan in ArcGIS Pro. Will that be available in the future?
Great question.
Yeah, that's a good question. That's something I also haven't seen lately. I might have to get back to you on that, but I'll have to dig into some GeoNet or even reach out to some product teams here. Do you know anything more, Linda?
I do not have the answer to that one. There's always one question I don't know, and that's it. we'll find out though. Yeah.
All right, great. Thank you both. And let's see, is ArcGIS Pro and its tools accessible on the internet?
Yeah, so kind of. There's a light version in Arcgis Online where you can use some ready-to-use tools. It includes some of the capabilities of the Arcgis Pro tools, and it's all online oriented. But then the main powerhouse for analysis and spatial analysis is going to be your Arcgis Pro. But there are some tools in your Arcgis Online or enterprise environments.
Got it. Okay.
Yeah.
Linda, did you have anything else?
No, just again, the tools in online continue to grow. I mean, there's a lot in there compared to even just a couple of years ago. But to Brady's point, if you want to do some real heavy lifting, if you want to do Bayesian kriging, you're going to want to use a desktop tool.
Great, thank you. All right, this next question here, it's kind of a long question, so if you both wanted to open up your chat, and I'll go ahead and read it out loud. It comes in two parts, so I will read the first part. This user says, I am trying to help my organization with maps for use in preparedness, crisis management, etc., but unsure of, in the first part, how to advocate for maps and their use. A lot of my coworkers are skeptical to using maps. So I'll let me just go ahead and read the second part. And number 2, which maps are most beneficial to demonstrate how useful maps can be in preparedness, etc. So I can spend my time making these maps analysis in order to gain traction in this field and advocate more for the active use of GIS.
Yeah, that's a really great question. And I think what I would advise is it really starts with your data. So if you're thinking about preparedness, emergency management, you want to bring together different types of information. So there may be information about, let's say, your citizens, some socio-demographic data about your citizens, age, other risk factors you might have, along with some of the real-time data that you can stream in. So organizations such as NASA, NOAA, many other have live real-time streams, right? I could grab incoming weather data. I could get buoy data off of NOAA for what's happening in the ocean. So there's a lot of different data streams that you could bring together. And I think if you did that, if you showed here's our population, here's who's at risk, and here is what is impending, and do maybe just a simple buffer analysis and say here is the area that will be impacted. Here's the total population that will be impacted. That is extremely powerful, and you can only get that by doing that visualization, by seeing that analysis through a map. You can't see that through a table. I don't know if Brady has any suggestions that he wants to add to that.
No, that's a great answer. Yeah, there's a lot of power in visualization of data, for sure.
All right, perfect. Thank you. And it looks like we just have maybe 1 or 2 more questions in here. So again, if anyone has any last minute questions, feel free to put those in the chat. And Linda, I believe I will throw this one to you. What types of analysis can you do with spatial stats?
Oh, wow. There are so many types of analysis. I mean, I touched on this earlier in the presentation, right, as far as different types, classification, regression analysis, clustering, but there are many different sophisticated types of analysis. I would encourage you again to maybe take a look at that Spatial Stats homepage, because they do a really good job of laying out the different types of analysis that are possible.
Great, thank you. All right, and I saved the best question for last. So Linda, again, I think I'll throw this one over to you. So what sessions will there be at Esri UC on spatial stats analysis, or sorry, spatial analysis and statistics? So if you have any recommendations, and again, any links that or resources that Linda shares, we'll go ahead and stick in that follow-up email as well.
Yeah, you bet. So a couple of great things coming up. We have a nice story map we've put together for you, so we'll share that link as well afterwards. That talks about all the various sessions at the user conference. We do have some statistical organizations that are presenting, including US Census, so I've highlighted those sessions so you can easily find those. We're also having a statistics SIG, a special interest group meeting. But throughout the week, you're going to find a lot of different spatial stats session, including a spoiler alert here, but we're going to introduce the new SAS bridge for ArcGIS. So if you are using SAS, make sure you're there to hear about that. So a lot of really good things. And, the ISI, the International Statistical Institute conference, is ongoing the same week as our user conference. This is the first in a series focused on statistics and spatial stats that we're doing together with ISI. We will have a workshop there, and I hope you can join us there, because we're going to continue this discussion on spatial statistics at that workshop as well.
Great, thank you. And that actually prompted a few more questions coming in, so we'll go ahead and address those. I think we have a few more minutes left. So the first one here, do you have any resources to learn more about the Network Analyst tool?
Yeah, so I can send you the link, but if you just search for the Network Analyst Arcgis Pro, there's going to be some tutorials there directly related to that extension. And it even gives you some data to use and download. So you don't have to either look for data, or maybe you can also just apply to your own. But it's ready to use and very straightforward as well. So.
Great, thank you. And this next question, and I believe, Linda, this question came in as you were explaining the answers of what types of analysis you can do with spatial stats, but I'll leave it up to the user to clarify if I got that wrong. The question is there any form or platform to keep learning about that and exchanging?
Sure. So Esri has a platform called GeoNet. It is our community for the community and by the community. And so it's where we encourage conversation, amongst Esri and users like you. So I would encourage you to join into the GeoNet community. That's where Kelly's going to place these resources, the recording and the slides. So that'll help you find where the landing page is for stats. We try and keep our current information up there as well and encourage questions, but the spatial stats team has a great spot on that platform too, and I would encourage you to get to know some of the other folks there. And of course, follow us on LinkedIn. A lot of good conversation going on there, and always introducing new things, such as the new 10-meter land classification data that went out just last Friday. So lots of good things.
Great, thank you. And more on resources, do we have resources to learn about spatial statistics model regressions with ArcGIS?
Yeah, so again, I'm just going to kind of plug in that Learn ArcGIS here. I'll put it in the chat for everyone to see. But if you go to the Learn ArcGIS, you can kind of search by your skill level in GIS. You can also just search by all content and then search for like keywords that you're looking for. Yeah, there's going to be model regression, there's going to be statistics, there's going to be advanced statistics, image classification, and all tutorials go for all those kind of classifications plus more. So plenty of stuff to work for.
And if you go to that Learn site and you simply type the word statistics, you're going to find the first thing that pops up is a website and a learning path. That has over 40 hours of content and lessons in it. So, sort of stepping you through different parts of the workflow, the statistical workflow.
Great, thank you. And all right, it looks like last but not least here, can you give me an example for a tool to use to make change diction on statistical data?
I think change detection, maybe. A little typo there. Yeah. So if you're looking to do change detection, I think when I think of change detection, I think about using Earth observation data and understanding it from a pixel level, what has changed. And perhaps I might want to do that to understand an area that used to be agriculture and is no longer, and I want to understand what is on that area now. So that would be a really good use of change detection. I don't know, Brady, if you have another example in mind.
Not really, but maybe just some specific tools would be raster difference or raster, I think I just had it up here, raster compare. So you can change to that pixel level. You can look at the two difference in comparisons. A raster calculator, you can perform a difference, so you can subtract those two rasters together and really get a final output for those differences. But those might be some specific tools for those workflows that you're coming up with.
Great, thank you both. And I believe that is all our questions. We are coming up to the top of the hour here, so we're going to go ahead and close this out. I want to thank everyone for participating, for watching those demos, for asking all your questions. We greatly appreciate that. And again, just as our last reminder here, we have recorded this webinar in its entirety, and we will be providing the link to that recording for you to watch at your convenience or share with your colleagues. Also, any of the resources that we went over today, I know we had a lot. We put some links in the chat, but we will also be including all of those links along with the slides, the presentation slides in that video recording. And that will be all posted on our Esri community page. So you guys can easily find not only those resources, but links to other resources as well throughout our entire Esri community. And as Linda mentioned earlier, don't forget to join us at our Esri user conference and also the ISI conference. I believe we're holding a tech workshop there as well. So you can get more information that you need. And I believe that is it. So Linda, did you have any closing reminders for anyone?
No, I think you hit it all, but I'm looking forward to hoping to see many of you at UC or ISI. So thanks for joining us. See you next time.
Great, thank you. And thank you, Linda and Brady, for your time today. We really appreciate that.
Thank you all.
All right,
Thanks,
thank you, everyone. Yeah, have a great rest of your day. Thank you.